Fix a white sheet of paper on a drawing board with the help of pins. Draw a line MM1 on the sheet of paper. At the center of the line MM1, take a point O. Draw a normal ON to line MM1 at point O. Now draw an incident ray, AO, making an angle to ON. Now, with the help of a stand, place vertically a smooth plane mirror on line MM1. Fix 2 pins P and Q upright on the ray AO. Observe the images P1, Q1 of P and Q from the other side of the normal in such a way that both of them lie on the same line. Now, fix pins R and S on the board in such a manner that P1, Q1, R, and S are all seen in one straight line. Encircle the position of pins R and S with a pencil. Remove all the pins and the plane mirror from the board. Draw a line joining the points R and S, extend it to line MM1 in such a manner that it meets at point O. Now ray OS is the reflected ray. The angle between incident ray AO and normal ON is the angle of incidence. The angle between the reflected ray OS and normal ON is the angle of reflection. With the help of a protractor, measure the angle of incidence, that is angle I, and the angle of reflection, that is angle R. Now, replace the mirror and position the pins P and Q in such a way that the angle of incidence changes. On the other side of the normal, place the pins R and S and observe the angle of reflection. Repeat the experiment a few more times and measure the angle of incidence and the angle of reflection each time. From these experiments, 2 important laws of reflection can be deduced. The angle of incidence is always equal to the angle of reflection. Incident ray, reflected ray, and the normal drawn at the point of incidence are coplanar, that is, they lie in the same plane. Note that the incident ray and reflected ray are on the opposite sides of the normal, or the perpendicular, at the point of incidence. Application of reflection of light. The understanding of laws of reflection has enabled us in designing instruments like a periscope. It employs the phenomenon of reflection of light to raise the line of sight